So this is the made easy plate clutch question which was of 2 marks. So understand this question because this is the different from what we have usually studied. A plate clutch is commanding friction clutch having two contact surfaces commanding n is equal to 2. When clutch is new, it transmits 150 Newton meter torque. The torque is equal to 150 Newton meter. The outside diameter of contact surface is 240, inside diameter is 120, and coefficient of friction lining is 0.3. The axial force is provided by 6 springs of stiffness 12 kN per meter. Means जो भी axial force आएगी F1 की वैल्यू वो किसने प्रोवाइड की है? हमने जब क्लच पैडल दबाया तब 6 की 6 स्प्रिंग कंप्रेस हुई जिसकी वजह से उतनी एक्सियल फोर्स आएगी. If due to continuous operation each contact surface gets weared by 4 mm, then the decrease in torque capacity of clutch is. Okay, so solving it, what we have to first find? We have to first find the value of axial force. Torque is given and torque is equal to 2 times the formula of torque. The initial clutch is new clutch, so constant pressure theory will act. So solving it like this, torque is equal to 2 times the formula, 150 is equal to 2 times into 0.3. Okay, so we get the value of P as P is constant, it comes outside, we get value of P is equal to something. Now F1 is equal to, in first case, F1 is equal to P into pi r naught square minus ri square. So we get the value of F1, which comes out to be 25355.9 divided by 2. 5355.9 divided by 2, 2679.5. Now we will find the deflection of each spring, because the deflection of spring only causes the axial force. So force we got is 279.5 is equal to number of springs 6 into k into x. So each springs get deflected by, so each spring get deflected by 37.19 mm. Now what the second part of the question says, change in torque capacity. Now as the clutch is weared out due to what continuous action, so there will be constant wear theory. So now how to solve this? First, what the formula of torque is? Mu f dot d, mu f dot r. Is for clutch mu going to change? No. R going to change? No. So of course the axial force is going to be changed to cause the change in torque. As he has asked the difference, so torque must be changing. So torque must be changing means axial force must be changing. Now we know the old clutch has less amount of torque and new clutch has more amount of torque. So F1 should be less, F2 should be less. So T2 will be automatically less. So how to find the value of F2? Now he told in the question is wear of 4 mm on each surface. That means 4 mm, 4 mm. So total 8 mm wear. Now the spring will get deflected by 37 point. We need less force, so 37 initial deflection minus 8, 31 mm deflection is caused by the spring in case 2. I don't know how, but this is how to solve this. 31 mm. Now kx 12,000 into 31 into 6 gives F2. Force 2. It gives torque 2. So torque 1 minus torque 2 will be the answer. Remember to multiply with 2 in torque. And in force calculation we don't need to multiply with number of plates.